Hello everyone, welcome to a new session of Physics Plus YouTube channel. Here we are going to discuss a very important chapter in class 9th, that is motion. We have been studying physics from our lower classes. Yes, right? Yes. We have studied friction, we know some kind of forces, right? But what I can tell you is the 9th standard is the fundamental base for the upcoming physics. If we understand the 9th standard physics concept very well, we are going to do a very good in our upcoming higher classes. Okay, so let's start our first chapter, that is motion. What is motion actually? Motion, it's motion, right? No. How you will define this motion? Yes, please. Motion is nothing but change of position of any body, right? If any body is changing its position, we can tell that that body is in motion. Why we want to study this motion anyway? Because we know that everything around us are in motion, right? But I am in standing mode. I am at rest, right? No, because I am standing in a classroom which is in the universe, which itself is rotating, or what we can say, it is revolving in this galaxy. So everybody we can say are in motion. Okay, so before coming to this motion, we want to know some fundamental basics in physics. What is physics actually? Yes, please. What is physics? What I can tell you is physics is simply nothing but the law of nature. What I can tell you is, if we understand the physics, we will just start loving physics. That is my guarantee. Okay, so where were we? Yes, we were in motion, right? Before coming to the motion, I want to give you two things in the universe. We will be mainly focusing about some quantities that can be named as physical quantities. In physics, especially in our 9th standard, we will be studying about those quantities which are categorized as a physical quantity. So what is a physical quantity? Physical quantity means the quantities which we can measure. Okay, clear? Which we can measure. So what all things we can measure? We can measure what? We can measure length of any object, right? We can measure the length, and we can measure what? We can measure time, we can measure mass, we can measure any velocity, many things. All those things we can measure, the force, we can measure the weight, we can measure pressure. All those quantities are named under physical quantities in physics. So in our every chapter in class 9th, we will be discussing about physical quantities. Okay, clear? So the question is whether light is a physical quantity. I told you that physical quantities are those quantities which we can measure. Can we measure the light? No, but we can measure the intensity of light, right? So intensity is a physical quantity, and we can measure wavelength of light, new term. Okay, we will coming to that later in our upcoming classes. Okay, so whether sound is a physical quantity, similar as light, what I can tell you is we can measure the loudness of sound, or the pitch of sound, or the intensity of sound. So those all quantities which we can measure, we can categorize everything under physical quantities. Okay, clear? So in our class 9th, we'll be dealing mostly about physical quantities. Clear? Okay. In physical quantities, we are having a main two categories. One is scalar quantity and the another is vector quantity. Very important concepts. Okay, listen please. What do you mean by a scalar quantity? For example, I need to measure the length of this chalk. Okay, clear? I need to measure the length of this chalk. If I am measuring the length of the chalk, I can measure in this direction, or I can hold the chalk in this direction. I am measuring the length. If I can measure, I can hold the chalk in any other direction. The length is not going to change. That means any quantity whose magnitude means value, is not going to change if we keep that in any other direction, is what we call as scalar quantity. Clear? So example is length. Length is a scalar quantity. Clear? How can we represent the length? This is the fundamental basics what I am giving you right now. Okay. How can we represent the length? Length can be represented in terms of centimeter, meter. What are these centimeter and meter? They are nothing but the units. We are hearing these words from our very basic classes, right? But now I am telling you the basic. What do you mean by units? For example, I am having certain amount of rice with me. Okay, somebody is asking me how much quantity of rice you are having. I am telling that I am having two rice. They will again ask 2 what? 2 gram, 2 kilogram, 2 milligram, right? We have to specify the amount. For that we need unit. In simple terms, suppose we are having 22 gram of gold in our hand. Okay, 22 gram of gold. Suppose we are measuring the weight of 22 gram of gold in our place, or we measure it from any other part of the universe. It should weight what? 22, right? Then only it will be accepted universally. Any physical quantities which we are measuring should not change according to the what? According to the places we are moving. That means we need a standardized format for what all things we are measuring. For that we need a units. Clear? So what will be the unit of mass? We know mass are measuring in kilograms, right? Mass are measuring in kilograms, or we can measure the mass in grams, right? We can say these are the units for mass. So my question, whether the mass comes under scalar quantity? Obviously yes. If I am measuring my weight, okay, suppose I am measuring my weight and it is showing suppose 65 kilogram, and if I am standing in some other direction and again I am measuring my weight, whether it will change? Definitely not, right? So this is again a scalar quantity. Okay, so scalar quantity means those physical quantity which have got only magnitude. Magnitude means the value. So next one is vector quantity. What is a vector quantity? So we can tell scalar is what? This have got only magnitude. Okay, very important, only magnitude. So what is vector? For example, suppose there is a door here. Okay, there is a door and there is a handle in the door, and I want to open this door, and the person standing nearby told me that you just have to apply 2 Newton force. 2 Newton force. Okay, so I'm applying 2 Newton force like this, pushing, but it is not opening. So I'm applying 2 Newton force, 5 Newton force, 10 Newton force. No. Then comes the person standing next to the door. He's coming and showing me that, hey, it is just simply 2 Newton force, but in outward direction. That means if I am applying a force in inward direction, 2 Newton force, it is not opening. The same force if I am applying in outward direction, the door is opening. That means force is a quantity which depends on magnitude plus direction. Clear? Vector quantities are those which have magnitude plus direction. Okay, example for vector quantity, I can tell you: force, velocity, then comes acceleration, and many more. Okay, is the concept clear? There is a slight difference in writing scalar quantities and vector quantities. For example, we told that length is a scalar quantity, mass is a scalar quantity, and time is a scalar quantity. So we can measure the scalar quantities as simply the SI unit as seconds, meter, that is for length, and kilogram. Okay, but for the vector quantities, listen please, I told you that force is a vector quantity. Force can be represented by with a bar, F with a bar. Velocity is a vector quantity, so we can represent velocity V with a bar. Okay, so we can identify from the symbol itself that those all letters with a bar, we can easily know that they come under vector quantity. Okay, moving on, we are discussing mechanics. What is mechanics? Mechanics is nothing but the study of motion. Okay, so in our first session we are studying about the distance and displacement. We know from our lower classes what is distance, right? What is distance? Suppose a body which is at A is moving on to C in 2 pathways. Okay, the first path is from A to B, then from B to C. Okay, this is the path number 1. The second path is from A to C directly. Okay, I want to know what is the distance and what is the displacement. You know, right? Yes, it's very simple. So what is the distance here? First path and the second path. In first path, the distance is the 5, suppose this is 5 meter and this is 3 meter and this is 6 meter. The distance covered in path is 5 plus 3, right? So distance is 5 plus 3. That means distance is the total path length covered, total path length covered. Clear? So what is displacement? Let us come to this displacement. The same figure I have redrawn here, 3 meter, 5 meter, 6 meter. So in this case, what is displacement? Here the displacement is 6. Why it is 6? Because it is the shortest path. Displacement is the shortest path between initial and final point. Okay, where is my initial point? This is my initial point. Where is my final point? This. So which is the shortest path? 6. It is not 5 plus 3, right? So displacement here it is 6 meter, and the distance here it is 5 plus 3, that is 8 meter. Clear? So this is a fundamental base. What is distance and what is displacement? Clear? Now we have to see displacement. Displacement, what I can tell you, is a vector quantity, very important, and distance is a scalar quantity. We have studied what is vector and what is scalar, right? Now let us see how the distance is becoming scalar and how the displacement is becoming a vector quantity. Let's see. Suppose our body is moving from A to B, then B to C in this format. Okay, but A to B is same distance as before, 5 meter, and B to C is also 3 meter as like our previous example, but the same body is moving like this, A to B like this, again 5 meter, and B to C like this, again 3 meter. Okay, so the question is, so the direction is like this, okay, and the direction is like this, and it is given as 6 meter in the figure. Suppose we want to write the distance and the displacement in the two cases. This is case number 1 and this is case number 2. Okay, what is the distance here? Distance is 5 plus 3, that is 8. 8 meter is our distance, right? What is displacement here? Displacement, what was the definition for displacement? It is the shortest path between final and initial. What is the shortest path? Again the same. So displacement and the distance is same here. Okay, but coming to this, we know the answer for this, right? What is the distance here? 5 plus 3, that is 8 meter. What is the displacement here? Shortest path, that is 6 meter. But in the two cases, I have moved with the same magnitude, right? Magnitude means what? Value, 5 plus 3, 5 plus 3. But when I changed my direction, my displacement have got changed, right? So that means what? Displacement is a quantity which depends upon magnitude plus direction. That means displacement is a vector quantity. Same as here for distance. The distance in the first case is 8 meter and the distance in the second case is also 8 meter, irrespective of the change of the direction. So what we concluded is the distance is a scalar quantity. That means it does not depend upon the direction. Is the concept clear? Very simple, right? Okay, let's do some problems based on distance and displacement. Then only we can check ourselves whether we understood what is this displacement and distance. Okay, so first question. An object moves from A to B, point B, then to point C, then back to point B, and then to point C. Okay, this is our question. Along the straight line as shown. Find the distance and magnitude and direction of the displacement. This is a very simple question and it is given in your textbook. Okay, so first let us see what is the question. An object is moving from A to B, then to C, then back to B, and then to C. We want to find the distance. We know what is the distance. What is the distance? Total path length covered, right? So what is the total path length covered in this journey? A to B. What is that? It is given as 1 kilometer, 2, 3, up to B it is 5. So the first is distance is, we can write for distance it is AB plus B to C, then it is BC, then C to B, then it is CB, then back to C, then it is BC. If we add all these terms, we will get distance. What is that? A to B, that is 5, then B to C, this is 9. So what will be B to C? Up to here it is 5 and up to C it is 9. So what is this? B to C? Yes, it is 4. So we can write 5 plus BC, it is 4, plus CB, again BC and CB are same, 4, plus again from B to C, it is 4. So 5 plus 4 plus 4 plus 4, what is that? 9 plus 8, that is 17. Clear? So that is the distance. Very simple, right? So let us see what is the second question. Magnitude and direction of the displacement. We know what is the displacement. Displacement is the shortest path between initial and final. Where is the final position now? To B, to C, to B, to C. So where is the final position? C. So what is the shortest distance between A and C? It is 9, total 9 kilometers. So the displacement is 9. What is the direction? Magnitude and direction. What is the direction? From along AC. Is that very simple? Yes, right? Let us look to the next example. Next question. An object moves from point A to point C along a rectangle as shown. Okay? And we have to find the distance and displacement. Okay, similar question but slight change in the figure. An object is moving from A to C along the rectangle. A to C along the rectangle. Where is the rectangle here? A, B, C, D is the rectangle. And along B, it is reaching C. Right? Then only it reaches C. So we can write it is moving from A to B, then B to C. So this is our starting point and this is our ending point, right? We want to find the distance. So it is very clear. We have to just add what? Distance is what? Total distance. So what is the total distance here? A to B plus B to C, right? Very simple. But the thing is, they haven't mentioned what is the side of this rectangle, right? It is not mentioned in the figure what is AB and what is BC. But they have given a small square units, like in the graph paper we have seen this small square brackets, right? So what is this small units value? It is given as 1 meter. They have shown this is 1 meter and this is 1 meter. So it is very simple. Distance is what? Distance is nothing but AB plus BC. Very simple. But we have to be very careful in adding this small units, because when we add this small square brackets, we will reach AB, right? So what does this AB stands for? 1, 2, 3, 4, 5 units. Each units having 1 meter. So what is AB? So AB we can write nothing but 5 meter. Plus what is this BC? It is not 5. It is how much? 1, 2, 3. So what is the total? 5 plus 3. That is very simple. What is that? 8 meter is the distance, right? Very simple. So what about the second one? Displacement. We know displacement is the shortest distance between initial and final point. What is that? This one, right? And it is mentioned this rectangle. Rectangle we have studied it in class. The angle is 90 degree at B, right? It is perpendicular. AB and BC are perpendicular. Perpendicular means 90 degree, right? So we can write Pythagoras theorem. What is Pythagoras theorem? Hypotenuse square is equal to base square plus height square, right? Because we need to find displacement with what? AC. So according to Pythagoras theorem, I can write AC square is equal to hypotenuse square is equal to base square, that is AB square plus BC square. Am I right? What is AB? We have just got what is a value of AB. What is that? 5. So 5 square plus what is BC? We have got the value 3 square. What is that? 25 plus what is 3 square? 9. So what is that? 25 plus 9. How much is that? We need the displacement. So AC is equal to root of 34. So that is our displacement. Clear? Let us see the next question. Very basic question. An object is moving from A to B, then B to C, then C to D as shown in the figure. Find the distance and displacement. Okay. So it is this is a figure. We can see it is a circular motion, and A to B, B to C, C to D, and one thing is missing, D to A. Okay. Suppose this is the question. I have slightly modified the question. D to A. Okay. So we need to find the distance and displacement. So distance means what? A to B, B, C, C to D, D to A. So what kind of motion? Circular motion. And we know what is the distance cover in a complete rotation in a circular motion? Nothing but 2 pi r. We have studied, right? Distance cover, that is a perimeter of a circle, that is 2 pi r. What is r here? R is what? Radius. We can see from the figure, this is shown as 3 meter, so this will be 3 meter, this will be 3 meter, and this will be 3 meter, right? So what is 2 pi r? 2 pi into 3. What is that? 6 pi. Okay, so 6 pi meter, that is our distance. Pi we can substitute as 3.14 or 22 by 7. That's up to you. Okay, so I'm just leaving here. What is displacement? In the first case, I have slightly modified the question. A to B, B to C, C to D, D to A. Displacement means what? Displacement means the shortest distance between initial and final point. My initial point is A and the final point is also A. So what is the displacement? Displacement is 0, because my starting point and the ending point are same. Okay, this is a very casual question and a very easy question. Suppose slightly I am modifying this question into another way. Okay, listen please. Suppose the body is moving in a circular motion and making 2.5 rotation. Okay, 2.5 rotation, and the question is same. Find the distance and displacement. Okay, suppose our question is like this. An object is moving in 2.5 rotation. What is the distance and displacement? Distance we know. What is the distance? 2.5 rotation. So this is one rotation, this is second rotation, this is half rotation. So what is the distance in one rotation? We know. What is the distance in one rotation? That is nothing but 2 pi r, right? 2 pi r. How many times it is making the rotation? 2 plus half. So 2 pi r is one rotation. So what about two rotations? 2 pi r into 2. That is for distance covered in the two rotations. So what is that? R, we know it is 2 into 3 into 2 into pi, right? R is 3. So 2 into 2 into 3 into pi. So what is that? 6 into 2, that is 12 pi is 2 rotation. And one more rotation is there, half rotation. Then only we can say 2.5. So in half rotation, what is the distance? This is half rotation. What is that? If this is 2 pi r, half of that, how much is that half of 2 pi r? That is pi r. What is r? We know. How much is that? 3 pi. So if we add that, 12 plus 3, 12 pi plus 3 pi, right? How much is that? 15 pi. Is that clear? So let me explain once again. If a body is making 2.5 rotation, what is the distance? Right? 2 rotation, 1 rotation we know it is 2 pi r. So 2 rotation will be 2 pi r into 2. That is 4 pi r. 4 into 3. How much is that? 12 pi. Right? So 12 pi is the 2 times rotation plus half rotation. Half rotation. This is half rotation. So half of 2 pi r, what is that? Pi r. We know what is the value of r? 3. So 12 pi plus 3 pi, 15 pi is the distance. What about the displacement? Please, what about the displacement? Displacement is the shortest distance between starting point and ending point. Where is the ending point? Here. What is the starting point? Here. So what is the shortest distance? This is the shortest distance. What is that? What is that? Yes, it is the diameter. What is the diameter of a circle? 2r. Right. What is r? 3. So what is the diameter? 2 into 3. That is nothing but 6. Okay, clear? Suppose I am slightly modifying this question into another format. Listen please. Suppose a body is moving from A to D along the circle. Along the circle, find the distance and find the displacement. Okay. This is the third question in circular motion. Okay. A to D, and this is same 3 meter. A body, an object is moving from A to D along the circle. What is the distance and what is the displacement? Okay. So distance, let us do the first question. What is the distance actually? Distance is from here to here. What is the value of here to here? Half of the 2 pi r. How much is that? AC plus CD is the distance, right? AC is how much? Pi r. Am I right? What is CD? What is CD? Listen please. What is the total number of rotation? What is incomplete rotation? What is the total distance? 2 pi r. Am I right? Yes. So listen please very carefully. So what is this AB? I am sure that AB is equal to BC is equal to CD is equal to DA. Right? In symmetric positions they are standing. Right? So we can divide this 2 pi r into 4 sections. That is AB plus BC plus CD plus AD. Am I right? So if we divide this by 4, we will get what? Pi r by 2. That is the distance of each portions. AB is equal to pi r by 2, BC is equal to pi r by 2, CD is equal to pi r by 2 and DA is equal to pi r by 2. Clear? So what is AC? Pi r. What is CD? Pi r by 2. So if we add, what is the answer? Taking the LCM, we can write 2 plus 1, that is 3 pi r by 2. What is the answer? 3 by 2. R, we know the value of R, that is what? So what is the answer? 9 by 2 pi. Clear? So that is the value of our distance. Clear? So what about the displacement in this case? Clear, right? So what about the displacement? Displacement is the distance between the starting point and ending point. This will be the displacement. How can I find this AD? How can I find this AD? Very simple. How? Because I know this is the radius. What is this? 3 meter, and I know this is also the radius 3 meter. So again this will be definitely 90 degree Pythagoras. So I can find this AD, nothing but AD, I am just naming this point as O. So AD square is equal to AO square plus OD square. Am I right? Right. So what is AO square? 3 square plus OD is again 3 square. What is the value? 9 plus 9, that is 18. AD square is equal to 18. So what about AD? AD is equal to root 18. Root 18 can be written as root 9 into 2. What is root 9? We know root 9 is 3. So root 2 as it is. So here it is, the displacement is 3 root 2. Clear? Okay, this is the end of our first session of chapter motion. We will see in our next session with the concept of speed, velocity, acceleration, etc. Okay, thank you so much.